What's up, guys? I'm going to recap, if you missed class today in math, what we did really quickly. We are going to talk about something called a fractal. This is not a long lesson. I'm just going to give you some basic idea of what a fractal is and some that you can do to doodle while you're on the phone, while you want to, I don't know, you're doing sidewalk chalk when you got some sort of cool drawing you want to do. And I'm going to kind of try and tie that in as best as I can to what we're learning about this core semester in Algebra 1. So the first fractal that I'm going to teach you, fractal is basically just a geometric drawing that is described by some simple set of rules that will typically continue on and you'll never be able to finish. So it's not really possible to draw by hand, but you can start to draw by hand, and the bigger you make it, I think the more fun it ends up being when you're done. So to draw Sierpinski's triangle, this is the first one that we'll do. I'm going to change my color to black. You do your best to draw an equilateral triangle, meaning all sides are the same length. All angles are, try that again, 60 degrees. That looks better. Okay, and a horizontal line coming across. That'll do. That will do. That's going to do it. All right, so what we do here is the rule for drawing Sierpinski's triangle is you start with a upward pointing triangle. And then what you do is you take that space that's in the triangle and you draw the largest, or rather you draw a large downward pointing triangle, and typically what you do is you're going to come down to the halfway mark on this edge and put a horizontal line at the halfway mark coming across, and then you're going to be connecting it to the halfway mark on the bottom line. Okay, so now what we've just done is we've created 3 more little upward pointing triangles. Now we have one downward pointing triangle. So in those 3 upward pointing triangles, I'm going to repeat the process that I just did. I'm going to draw, kind of cut it in half, connect to the middle, so on and so forth. And then we can go again. So feel free to fast forward and skip ahead. I'm changing colors each time. You do not have to. I think it makes it a little more enjoyable to look at when you're done. So you start seeing a little bit of a pattern here as we're continuing to draw. As we continue to draw our fractal, you'll notice, and I know my triangles are not perfect, you'll notice the number of triangles we draw each time is increasing rather rapidly. So what I'm going to do in black is I'm going to talk about the steps. So we've completed kind of step 3. So step 1, we drew the blue triangle. Step 2, we drew the purple triangles. Step 3, we drew the red triangles, and this process could continue. So this is kind of the step number that we are on. Let's go on, and then in this next column we're going to write the number. This is the number, making a little table here, the number of new triangles that we drew. So in step 1 we drew one triangle, in one new triangle, it was blue. In step 2 we drew 3 new triangles, they were purple. In step 4 we drew 9 new triangles. Or step 3, sorry. Step 3, we drew 9 new triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9 in red. And step 4 would be how many? So take a second to think about that. So I could grab my green pen, and I've created more upward facing triangles, so I could go through and continue this process over and over and over. All right, so I'm not going to draw all these, but how many would there be? Well, there'll be 3 in each of these, and there's 3 of those here, and there are 3 of those things. So we're talking about 3 times 3 times 3, which means we will have 27 triangles. So my question to you, new triangles in green once we're done drawing. My question to you is, how many triangles would there be? How many new triangles would we have to draw for round 20? When I get to the 20th round of completing and drawing triangles, how many of them will there be? Kind of interesting to think about. You know what this is making me want to do? It makes me want to go home and do a really, really big one of these. I think that would be agonizing, but it sounds kind of fun. Horrifying, but fun. Anyway, so let's go through here. You may have noticed that each step, when we go to the next step, we're multiplying by 3. So to get to step 5, if we want to know what happens at step 5, we simply multiply by 3, or that will be 81. There will be 81 of those triangles that we would have to draw. On step 6, we take 81 and we multiply by 3, and so on and so forth. So it turns out this is the number of new triangles that we would have to draw. You could make another column here for the total triangles, right? And now that would be different. So on iteration 1, there would be 1. Iteration 2, there would be 4. This would be 13. This would be 40 as we continue down. So step 4 would be 40 triangles total. And again, I'm only counting these kind of downward pointing ones that we are drawing here. So my question is, how many are there for step 20? Well, don't sit there and multiply by 3 until you get down to step 20 and complete the table. There's a faster way to do it because we're math people and we can come up with a pattern. Now that pattern is, these are actually the powers of 3. So step 2 is 3 to the first. I'm going to erase this. Actually, step 2 is equal to 3 to the first. Step 3 is equal to 3 to the second. Step 4 is equal to 3 to the third. Step 5 is equal to 3 to the fourth. So you can see the relationship between the step that we're on and the power of 3 that we are dealing with. Remember, 3 to the first is just 3. 3 to the second is 3 times 3. 3 to the third is 3 times 3 times 3. 3 to the fourth is 3 times 3 times 3 times 3. So it's really just repeated multiplication. The number of 3's present in the product is what it is. So this process will continue. So if I want to find how many new triangles I'm going to draw at step, I won't be able to find the total. That would be a different problem altogether. But if I wanted to find the number of triangles that I would draw at step 20, that would be 3 to the 19th. If you plug that into your phone, if you want to plug an exponent into your phone, again, you can simply just do 3. If your exponent has this symbol, you would use that symbol. It's called the caret. Okay. 3 caret 19, or sometimes they have this button that looks like x to the y. So 3x to the y 19 is also something that you can plug in. So I'm going to go ahead and do that now. So this would be like if you have an Android probably, and then I think an Apple phone would be this one down here. It's a big number. It is 1,162,261,467. Okay? So that's how many new triangles you would have at step 20. So yeah, I'll race you to the finish line. Go for it. Just kidding. Okay, this is a fractal. It has a simple set of rules for drawing it. This is called the Sierpinski triangle. And I want to show you one more. So we can predict how many triangles we're going to draw in each step. If we wanted to get the total, we'd have to add all these up, which is, I'd probably rather just do that with a computer rather than try and do it by hand. But anyways, this is a fun one to draw when you're bored, and now I want to draw a very, very, very large one. Anyways, so let's go ahead and go on to the next one that I'd like to show you. If you have time to look up the Mandelbrot set on YouTube, I would recommend that. But for now, we're going to do this one, which is also a fun doodle. Apollonian gasket, I think is how you spell that. I've had trouble spelling that in the past. And a fun way to draw an Apollonian gasket, or the way that you draw an Apollonian gasket, is you draw some sort of a shape. You might draw like a kite shape, like this. You can draw like a kite. I know it doesn't look like a great kite, but you can draw kites, you can draw triangles, and what I want you to do, and this is for points, for your first assignment here, is I want you to draw a great big triangle, or a great big rectangle, or a rhombus, or a trapezoid. You can do whatever you want. I'm going to keep it simple and do like a triangle like this. I'm not going to do a triangle. Triangles are boring. Let's go like this. Triangles aren't boring. Triangles are amazing. But little math teacher guilt getting laid on me. I'm going to do like kind of a weird looking quadrilateral here. So you can draw some sort of a shape to create an Apollonian gasket. Now what we do is inside that shape, let me take this line away. Inside that shape, what you want to do is you want to draw the largest possible circle that you can. Now when I'm drawing on paper, what I recommend you do is do it really lightly. Now I can't do it really lightly because my pen only detects on or off. It doesn't detect, how hard I'm pressing. So I would recommend you do that on paper when you're doing it, is just kind of draw a circle until you see the largest circle. I can kind of go over it with my pen here. So I kind of see where it's at. It looks like it's maybe right about there is the one that's going to fit. I can kind of see it, so I'm going to turn my pen on. I'll change my colors. We'll do it purple. I'm going to try it one more time. It looks like it's right about... Oh, geez Louise, try that again. Right about... Whew. Okay, that is a horrible circle. One more time. Looks like it's contacting right here, and right there, maybe? So we're going to try and draw that circle as best we can. I'd like to see a replay of my face right there. Okay, so that's as good as it's going to get for me. So you draw the largest circle that you can fit into that space. And then what that has done is it has created 3 negative spaces. So the largest circle here is probably down in this corner. So you can fill that in. And then I'll come through here and we're going to continue this process. It's very similar to the Sierpinski's gasket, except we're dealing with circles. I think this one ends up being a little more pretty. I don't know why. So you can come through and continue in all the voids. So this one didn't create, well, it did create 3 voids, but one of them is very, very small. Right there, we can't see it. So the voids aren't the same size. This one, we've got a void there. Got a void here. We got to fill. We've got one right there. All right, and so we can continue this process. What I want you to do is create your own Apollonian gasket. I want you to go crazy. Create a weird shape. I think really long triangles create interesting Apollonian gaskets. Draw one out, take a picture, submit it on Google Classroom. And if you want to go as far as counting the circles on each step, be my guest, but you are not required to. Okay, so you can continue this process. My pen is very, very thick, so it's kind of hard to see, but if I really wanted to get technical, I could start zooming in and doing stuff like that. Anyways, that's an Apollonian gasket. I want you to draw your own. Do lots of circles. You should end up with these open circles, and you want to fill in all those little cracks and crevices. Okay, that's it for me. Hope you liked the video. I'll see you next time.